everybody, welcome to another episode of Daily IoT. Today is the day that we start on our Internet of Hockey project. For those that haven't watched it, I'll put a link up, a little card here in the YouTube video to link you to the previous video that explains what we're going to be building. But I've got the plan here in the background of how we're going to get started. And a lot of times on projects like this, you have a big idea and we have a general idea. We got pieces like the NHL API and Losant and our puck that we want to stick a screen on. And sometimes it's hard to know where to start. Do I start messing around with the API? And the trick is, or the secret is, you just start anywhere you want. Sometimes, obviously there's a flow. You got to start and get certain things accomplished before others, but don't get overwhelmed when you have a new project. Just take it one step at a time, find one piece to work on and go from there. And so that's what we're going to do in today's episode. We have this idea of sticking, I've got the bobblehead, maybe a stand, but the puck. In either scenario, we want to stick a screen, whether it's inside the puck or beneath the bobblehead. And so our first step is to have some sort of screen. Now, I talked about one of the goals of the project being using an e-ink display. Well, I don't have any e-ink displays yet. And so I have ordered one from Crystal Fonts that should be here in a few days. There were a few available from China on eBay, but the shipping was like anywhere between October and like the end of my life. And I didn't want to wait that long. And so I went ahead and I paid extra. I went with Crystal Fonts. It's local here in the United States to me. Should be here in a couple of days. However, I don't need to wait for that display to get here to start the flow of having a display at the end device that we can start working with. And so what we're going to do today is I mentioned we're going to use a particle photon. So we're going to take our particle photon, we're going to take this little segment, 7-segment multiple digit display and get it up and running, and so that we can at least have a base of code on our end device that we can start playing with. Because at the end of the day, this is just going to be something like update screen and firmware. And then when I get my e-ink display and I start playing with that, we'll just change the contents of that function to not use this anymore. We'll swap it out for our e-ink display. And so we're going to take our photon, slap it on a breadboard here. We're going to actually just stick the display right next to it like that. And now all we have to do is write a little bit of code. I've actually written several projects that use this display, so I already have code up in GitHub that I can grab on a moment's notice to get this display up and running. So that is what we're going to do today. We're going to get the baseline of the Photon project built up with a display that we can update with a value before we integrate it into things like Losant. And so that is where the project is going to start and take shape. And so let me show you how we do that. I've talked about this display before, and what I love about it, it's a little breakout from SparkFun. I can put the part number or link down in the description, but you can control it through serial, SPI, or I2C. And so whatever you've got available on your platform, this little display can handle it. It's just a simple digit display. And so all we need, we're just going to use the serial approach because we only need 3 wires, power, ground, and the transmit pin from the photon going into the receive pin on the display. So let's go ahead and hook that up first. Okay, we're all hooked up. One other thing I want to mention about this, I use the term voltage language sometimes when I talk about connecting two components together. You always want to make sure that they speak the same voltage language. And what I mean by that is this display can run on, I can't remember what its operating range is, but it's at least 3 volts up to, I think, 5 volts. But you never want to connect things that don't speak the same voltage language directly together. So like if the photon, which operates at 3.3 volts, let's say it was an Arduino and it operated at 5 volts and the pins on this were only 3.3 volt tolerant, you can't just connect them straight together because you could end up burning out pins on your screen without using some sort of level shifting techniques. And so what I really like also about this screen is that it is able to operate in the 3.3 volt range, and so we don't need any extra circuitry to connect these two things together. We just go straight from the photon over the display, 3 wires, and we are hooked up and ready to go. Okay, I have my photon connected to my laptop. I'm gonna just come down here. I've already logged in. If you're new to Particle Dev, you just come up to the particle menu here, and if you're not logged in, there'll be a login option. Log into your particle cloud. account. And so you can see it says no devices selected. I'm just going to go ahead and select my microcast Photon, which is what this particular Photon is. And now I'm ready to start writing code for it. What I will do first is come over here to the side, this little code thing, and I'm going to start a new project. And we're going to call this, I don't know, Hockey IoT. Nope, let's call it IoT Hockey. I don't know why that makes a difference. We're all set up here. We've got a README. We will adjust that later. So we'll get rid of that. We can close this untitled. And now under the source folder, you'll see I have iothockey.ino. And it's an empty project file that has a setup and loop. And so all we have to do now is put in a little bit of code to get our display working. And to do that, we're going to use code that I wrote previously. We're going to come over here to Chrome, and you can see this. I did a Christmas countdown project last year, counting down the days to Christmas, but I used the same screen. And so I wrote a bunch of functions that allow us to either use serial SPI or either approach. And so I'm just going to copy all of this, configure comm channel, write the screen. I need the clear display, set cursor position. Just grab all this code. It's code that I've already written that I can just reuse straight away. So go ahead and paste that in here. And because I'm not going to use SPI, and I'll probably get rid of a bunch of this, we're going to go ahead and clean these functions up. And now they just use serial, very simple, just one-liners on all of these. Okay, so now we just need to take care of the setup. Let's see what I did here before. I have not rehearsed this ahead of time. It's pretty raw. Configure comm channel and clear display. Okay, we don't need to parse target date. And the configure comm channel is, let me talk about that for just a second. Oops. Okay, so we come down into setup, and we'll go ahead and put this code in here. Now, you can see that I call configure comm channel, and let's take a look at that briefly. All we do in configure comm channel is serial1.begin, and so what a lot of people will ask is why not just do serial1.begin down here in the setup? And the reason for that is that it adds a layer of abstraction so that when we change out our display later, I don't have to come into the setup function and make a bunch of changes. Maybe the setup or initialization for the e-ink display is 10 lines of code. I don't know. My setup function won't change. All I'll do is come up here to configure comm channel and edit the contents of this up here. And so it just gives you a little bit of a layer of abstraction to be able to swap out components in code later without affecting things like your setup and loop flow. So that's why we do that. Okay, so all we're going to do for setup is configure comm channel and then clear the display. All we have to do at this point is write a little bit of code to make sure that our screen is working. And so what we'll need is a global variable here. We'll call it byte A equals 0, keeping it very simple at this point. And each time through the loop, we'll clear the display, and then we'll just write that to the screen. Now I'm choosing a byte because the way the screen works is it will display 0 through 9, but then when you send it a 10, it's going to say A because that's ASCII A or hex A, and so that's just the way that this particular display works. So we'll just mess with 0 through 9. Again, we don't need to worry about making this display do everything perfectly because we're going to swap it out for an e-ink display later. So let's just do a write to screen of A, and each time through we'll increment it. So we'll do A++, and then we'll say if A is greater than 9, let's just set it back to 0. So we'll just loop 0 to 9, back to 0. And then each time through, we'll do a delay of, I don't know, about 2 seconds. Sounds good. And all right, let's hit compile here, see what happens. Okay, compiler timed out or encountered an error. Let's click on that. Okay, So this was supposed to be fixed in the latest version of dev. Apparently they're still having some issues, but you can see I clicked on compiler timed out or encountered an error, and then I get there were no compiler errors. So if you get this in particle dev, just open up your terminal and try to compile it with the command line tools, and you'll see all the output there. So we'll just do particle compile the platform that we're using, which is Photon, and then just / for the current directory. I'm in my IoT directory, as you can see there. I'll just hit enter, and it will compile it, and then it will show us all the output. Again, I'm not sure why this is still not showing up in particle dev, but oh, okay. So clear command, cursor command. When I copied the code over, I missed the defines at the top. So there they go, right here. So let's grab these, Control C, pop back over and just throw those in up top here. And we should be good to go. Let's try to compile it at this point, compiling in the cloud, and success. Okay, we are now ready to try to program. So let's do that. Let's hit the little lightning bolt here. That is the flash. Okay, so what it's going to do is it's flashing green. It's going to go through a couple series of lights here. Sorry, I can't pull this up more. I'm tethered. And once it gets connected, the zeros that are showing up are just glitches from the wires being interrupted for the reboot. And then now, all right, cool. So I don't know if you can see that, but I'm getting 1, 2, it's on 3, 4, counting up. So that's it. That's all we're going to do today. We're taking this in small chunks. We have a display now. So looking back at our thing, we have a connection here that we can start messing around with, because really what I want to do next is move on to the Losant portion of this, where we're trying to control or send data down to our Photon to display on the screen, whether that be stats or numbers or anything else. Now we have a little test bed that we can start working on while we wait for our e-ink display to send data down from Losant. That's it for today. I appreciate everybody joining. If you haven't subscribed, you're definitely going to want to hit the subscribe button that appears somewhere on the screen here. And stay tuned. I think the project's coming along here very nicely. I appreciate everybody watching Daily IoT, the show where together we're learning how to make the Internet of Hockey one day at a time.